In the previous video, we looked at this function, and so let's reconsider f of x equal to x minus 5 over x squared plus 2x minus 35. And in the previous video, we established, and so we now know that f of x has a vertical asymptote at x equal to -7. And we knew that because direct substitution gave us -12 in the numerator and 0 in the denominator. So we knew this was true already. But the question that we also have is, where else does f of x have a discontinuity? And our algebraic minds can already see that this denominator right here is going to factor. And so let's go ahead and do that. Let's look at f of x equal to x minus 5. This does factor. We get x plus 7, which was why we had that asymptote at -7. But our other factor is x minus 5. So we know because of this right here that there is a discontinuity at x equals 5. The question is, why is it not a vertical asymptote like it was with x equals -7? And that's because if we were to simplify this, we would be able to divide x minus 5 out of both the numerator and the denominator. And so since x minus 5 divides out of the denominator completely, and that's going to be an important word here when we look at our next function, but because it divides out completely, in other words, if I were to cancel these out, I wouldn't have any x minus 5 issues left in the denominator. I still have the discontinuity because of the way my function is originally, but it divides out completely. That tells us that f of x has a removable discontinuity at x equals 5. And you can probably intuitively see what would happen here. If those divided off, I could reevaluate the limit as x approaches 5. Those two would be gone, and I would end up with the limit as 1 over 12. The limit exists, and so we can say there's a removable discontinuity there. What about the function g of x equal to x minus 2 in the numerator and x squared minus 4x plus 4 in the denominator? And I really want to look at this function at x equal to 2. Well, if I substitute 2 in, I get 0 in the numerator. The denominator looks a lot like 4 minus 8 plus 4. I get this 0 over 0 result, which in the past, when we've talked about limits, has meant apply something algebraically. And so what we can do if we look at this function here is we can factor the denominator, and this actually is x minus 2 times x minus 2, or x minus 2 quantity squared. Well, now if I divide off this x minus 2, I can rewrite it and look at it as the function that it behaves like 1 over x minus 2. But because this x minus 2 didn't divide out completely in the denominator, the way that x minus 5 did up here, I still had an x minus 2 left. If I were to try direct substitution again, I get 1 over 0. And so I can say g of x, even though we got one of the x minus 2's to divide out, it didn't divide out completely, so g of x has a vertical asymptote at x equals 2. So just a reminder that just because a factor does divide out of the denominator doesn't mean you can't still have a vertical asymptote there. So make sure you can see the difference between what happened with g of x and what happened with our function f of x in terms of removable discontinuity versus vertical asymptote.